Good morning. Today we are going to see the types of ionic crystal structures. Ionic compounds are suitably divided into two groups, that is Ca and Ca2, where C stands for cation and A stands for anion. This classification is based upon the relative numbers of positive and negative ions. The common typical example of these two types are for Ca type NaCl, cscl, ZnS, and for Ca2 type CaF2 and TiO2. Common crystal structures. The commonly occurring simple ionic substances crystallizes in one of the following six structures. First, sodium chloride structure, NaCl. It has face-centered cubic structure, FCC. Second, cesium chloride structure, cscl. It has body-centered cubic structure, BCC. Third, zinc sulfide structure. It is zinc blend structure. It has cubic close packing CCP structure. Fourth, zinc sulfide ZnS word site structure. It has hexagonal close packing structure, HCP. Fifth, calcium chloride CaF2. It has fluoride structure. And sixth, titanium dioxide TiO2. It has Rotel structure. That means all the ionic solids of Ca or Ca2 type, they can be commonly crystallized in these out of these six structures, and we can have the structure which will be divided in these six types. The type of ionic structure is mainly decided by the relative sizes of anions and the charge on the ions. We are expected to study only face-centered cubic and body-centered cubic structures here. The radius ratio is useful predicting the type of crystal structure. The radius of Na plus ion is 0.96 angstrom unit, and that of Cl minus ion is 1.81 angstrom unit. Thus, the radius ratio Rna plus upon Rcl minus is equal to 0.96 upon 1.81 is equal to 0.525. This value lies between 0.414 and 0.732. It suggests an octahedral arrangement of the ions in the crystal structure. Each Na plus ion is surrounded by 6 Cl minus ions at the corners of regular octahedron, and similarly each Cl minus ion is surrounded by 6 Na plus ions. It is shown in the next figure. The common coordination number of any Na plus ion as well as that of Cl minus ion is 6. In this case, positive and negative ions are alternately arranged. See the structure of NaCl crystal, the sodium chloride structure. Here Na plus and Cl minus, they are alternately arranged. The small dark circle indicates Na plus and somewhat larger hollow circle indicates the Cl minus ion in the structure, and we have the alternate arrangement of Na plus and Cl minus throughout the structure. If we look at the center black spot representing the Na plus ion, then 6 white circles represent Cl minus ions are the nearest spots or ions surround it. The sodium chloride structure is a common type and is known as rock salt structure. If we look at the central sodium ion, then it can be said that the Cl minus ions are found at the 8 corners of the cube and also at the center of each of the unit cell. This arrangement of ions in the crystal lattice is called as the face-centered cubic lattice, FCC. All the alkali metals halides except the cesium, the alkaline earth metal oxides and sulfides show this type of structure. The common cation and anion possesses the same coordination number, that is 6. Cesium chloride structure. Next one is the cesium. The radius of the Cs plus ion is 1.69 angstrom unit and that of Cl minus ion is 1.81 angstrom unit. Hence, the radius ratio RCS plus upon RCl minus is equal to 1.69 upon 1.81 is equal to 0.93. This value is close to 1, which suggests that the coordination number should be 8 and it should have a cubic structure. The structure of cscl is represented in the figure. Cesium chloride is interesting because both Cs plus and Cl minus ion are of the same size. Hence, it is not possible for these ions to form a close packed structure. The simplest way for these ions is to have simple cubic structure. Each Cs plus and Cl minus ion has 8 Cl minus ion as the nearest neighbors and vice versa. The coordination number of both the ions is 8. See the structure of cesium chloride. At the center there is a large dark circle, it is Cs, and hollow circle at the 8 corners of the cube, and thus they will be form such cubic structure which is followed, or which different ionic solids which have the nearly the same size, they can form such type of the structures. It can be considered that in cscl structure, each Cs plus ion occupies the center of the cube and Cl minus ions occupy the 8 corners of the cube. In a similar way, each Cs plus ion may be considered to occupy the corners of the cube. The two cubic structures that interpenetrate symmetrically as shown in figure. Note that this structure is neither close packed nor in a true sense body-centered cubic. In a body-centered cubic arrangement BCC, both the atoms at the center and at the corners are identical, whereas in cscl structure, the ions in the body center and corners are different. It must be described as body-centered cubic type of arrangement rather than body-centered cubic. CSF has NaCl type structure because of the smaller size of F- ions. CSBr and CSI also possesses cscl structure. Effect of temperature on the coordination number. It has been observed that one type of structure can be converted to other at different temperature. For example, one CSCl structure, coordination number 8, can be converted to NaCl structure, coordination number 6, at 490 degrees centigrade. Second example, NH4Cl compound having CSCl type structure can be changed to NaCl type structure at 184 degrees centigrade. Thus, increase in temperature decreases the coordination number. The effect of pressure on the coordination number. It should be noted that high pressure increases the coordination number. For example, compound like LiCl, LiBr, NaCl, KCl, KBr, RbCl, RbI, etc. have NaCl type structure, coordination number 6, which can be converted to coordination number 8 at high pressure. Zinc blend structure, ZNS. It is a Ca type of ionic solid. It possesses two types of structures, as first zinc blende structure and second Wurtzite structure. Very few ionic compounds come under this type, which can show the two types of structure. First we see the zinc blende structure. Zinc blende structure ZnS, the radius ratio is radius of Zn++ upon radius of sulfur minus minus is 0.40. This value 0.4 suggests that the coordination number is 4. Each Zn2 plus ion is in contact with only 4 S twice minus ions. Thus, in this structure, the cation Zn2 plus is surrounded by 4 S twice minus anions at the corners of the regular tetrahedron and vice versa, which will be shown in the figure. The coordination number is 4. See the zinc blende structure, cubic close packing CCP arrangement. In this type of structure, the 4 S twice minus ions are present in the cubic close packed CCP type. ABC sequence of layers in the packing structure, and the tetrahedral holes are occupied by Zn2 plus ions. Thus, this structure will be formed. While we see the Wurtzite structure, that is ZnS, it is similar to that of zinc blende structure. The only difference between these two is that in the zinc blende structure, the S twice minus ions are arranged in CCP type, cubic close packing type, whereas in Wurtzite structure it is HCP, hexagonal close packing type structure. The coordination number of Zn2 plus and S twice minus ions in both cases is 4. Then we are going to see the next type of structure, fluorite structure, CaF2. It belongs to the Ca2 type structure of ionic solid. Here the proportion of Ca2 plus to F minus ion is 2:1. The radius ratio in CaF2 is 0.73. Thus, we predict the coordination number of Ca ion is 8. It means that each Ca2 plus ion is in contact with 8 F minus ions, and each F minus ion is in contact with 4 Ca2 plus ions. Thus, the coordination number of Ca2 plus ion cation and F minus ion anion is 8:4 respectively. Other examples of BaF2, BaCl2, SrF2, SrCl2, CdF2, PbF2, etc. That means Actually in structure, in case of CaF2, it is 1:2 proportion. Next we are going to see the Rotel structure. Again it is a type of Ca2 type structure. See, this Ca2 type structure is found in the compounds having radius ratio between 0.41 to 0.73. In TiO2 Rotel structure, titanium ions are in a planar triangular arrangement. Thus, the coordination number of Ti4 plus and O twice minus are 6 and 3 respectively, as shown in figure. See, these dark smaller ions are the titanium 4 plus ions, and larger hollow oxide ions. A formula for this is the TiO2. It is called as Rotel structure.